Hi, Mr. Eaton here, and today we're going to use Pythagoras' theorem to find the shorter sides. But before we do, just a quick bit of revision, remembering that Pythagoras' theorem is c squared equals a squared plus b squared. So have a go at solving the hypotenuse over here. We know one of the shorter sides and we know the other shorter side. Using Pythagoras' theorem, find the length of the hypotenuse for me, please. Put the video on pause, come back when you're ready. Alright, so you should have had something like this: 3 squared plus 4 squared, so 3 3s are 9, plus 4 4s are 16. We add the two together, we get 25, and that is true for c squared. C therefore equals the square root of 25, and c therefore is equal to 5. So this is equal to 5 units. Well done. Alright, we can actually rewrite Pythagoras' theorem, which is c squared, which is the subject on the left hand side, equals a squared plus b squared. Now if we wanted to find a squared, for example, we can move the b squared to this side of the equal sign, so therefore it would become minus b squared. So over here we have c squared minus b squared equals a squared, because we want to find a squared. So we can rewrite it if we want to as a squared equals c squared minus b squared. Exactly the same happens if we want b to be the subject, or b is what we actually have to find. We can go c squared minus a squared equals b squared. So we've got b squared all by itself, and we can rewrite that again if we wanted to as b squared equals c squared minus a squared. So all we've done is just rearranged our Pythagoras' theorem by moving a squared across the equal sign, or b squared across the equal sign, to rearrange our formulas. Well, let's put that now into practice. Looking at our right-angled triangle, we can see that the hypotenuse is 17, so we know that, and we know one of the shorter sides is 15, but the other short side we don't know, therefore we've called it a. So Pythagoras' theorem is c squared equals a squared plus b squared. Now I'm wanting to find a by itself, so I'm going to go a squared equals c squared minus b squared. So what I've done is I've just rearranged my formula to get the subject, or the side that I need to find, all by itself, and I know what the other two sides are. Okay. So I have c squared, which is going to be 17 squared, subtract 15 squared, and I know that 17 squared is 289, and 15 squared is 225. And if I subtract 225 from 289, I end up with 64, and again that's true for a squared. So to get a by itself, I have to find the square root of 64, and the square root of 64 happens to be, well, 8 eighths or 64. So side A is going to be 8 units. Right, well here's another practice one for you. Our right-angled triangle, with our hypotenuse being 10. One of our shorter sides is 7.6 units, and we don't know the other side, so we've labelled that one side X. So what I need you to find is find the length of the shorter side. Put the video on pause, come back when you're ready and see if you got it right. Alright, well, Pythagoras' theorem, c squared equals a squared plus b squared, and in this case I'm going to call one of my shorter sides x. So I'm going to have x squared is equal to c squared minus, and I'm going to call it a squared. Alright, so c squared is going to be my hypotenuse, so 10 squared subtract 7.6 squared. So that equals 100 subtract, well, 7.6 squared happens to be 57.76. So 100 less that amount is going to give me 42.24. And therefore I need to find x. So the square root of 42.24 is going to give me 6.50, and that's correct to 2 decimal places. Alrighty, so x is equal to 6.5 units. Hope you got that right. And that's how you go about finding one of the shorter sides in a right angle triangle when you know the hypotenuse and the other short side.